I'm going to review how you divide with fractions. Whole numbers divided by a fraction, or a fraction divided by a whole number. Fractions divided by fractions, along with mixed numbers divided with fractions. In our first example, we have a whole number divided by a fraction. So what this really means, if you were to have a word problem, your dividend is your first number. This means the total, how much we have all together. As you can see, we have 6 total pieces right here, and we're going to put them into groups of 1/3. So that means we're going to take our total and we're going to divide it into thirds. So if I had to draw a line into thirds, now I'm going to look at see how many pieces I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I can say 6 divided by 1/3 is 18. If I were to solve this with just an equation, if I wasn't able to represent it with the model, I would have 6 as a fraction, which is my whole number. I would do the reciprocal of my second, so then I would flip 1/3 to 3/1. That's the reciprocal. And since I'm doing the reciprocal, then I'm doing the reciprocal division, which is multiplication, and I multiply across. So 6 times 3 is 18. 1 times 1 is 1. And as you can see, when it's simplified, we get the same exact answer as when it is represented with the model. Here are some questions to practice with. 5 divided by 1/4. 3 divided by 2/3. Let's go with 6 divided by 1/8. And 4 divided by 2/5. So pause this, practice these 4 equations of setting it up of where you have the first number stays the same as a fraction. You do the reciprocal of the second number, where you flip it and you do the opposite of division, which is multiplication. Alright, so this time we're going to look at a fraction divided by a whole number. So this time we will have 1/2 as our total. So we could have half a cookie, half a cake, half a watermelon, half of a candy bar, whatever half is. And then we're going to divide it into 3 equal parts to see how much each of those parts are equivalent to compared to the whole. So as you can see, I have a whole down here, but we are really going to just focus on this half a piece. So what we need to do is that we're going to divide the whole thing into thirds, and I'm going to redo that third because it was awful. There we go. That's the best I can do. Okay, so when we look, we have 1, 2, 3 pieces, but we still have to keep in mind what the whole actually looks at. So when we see this and we look at this one piece right here, we can see that we really have 6 pieces out of that whole, and this one shaded in spot is 1 out of those 6 pieces. And whenever we look at that as an equation, as we did previously, we have 1/2 stays the same. Our 3, which is actually 3/1 as a fraction, we write the reciprocal of, which is 1/3. We do the opposite of division, so that's multiplication. And we're going to multiply across. 1 times 1 is 1. 2 times 3 is 6. And that's how we can see, as a model, that's how it's represented, and then in an equation as well. Alright, so let's practice doing the same thing. So let's say we have 3/4. We're going to divide it into 5 pieces. We have 1/3, dividing it into 4 pieces. 2/5, dividing it into 2 pieces. 3/6, dividing it into 6 pieces. So try those 4. Either with an equation, draw a model, practice, pause this, practice before you move on to the next example. So now we have a fraction divided by a fraction. So I have 1/4 divided by 2/3, and this is the way we're going to model this. So I'm going to shade in 1/4 right there. And then over here, I'm going to shade in 2/3, okay, to kind of represent it. And my last square over here, I'm going to draw my 1/4 again, shade that in, okay, and then I'm going to take my 2/3, draw those as evenly as possible, and then I'm going to go ahead and circle my 2/3, okay. So the way this is going to work is our numerator is going to represent our squares that are shaded in. So I have 1, 2, 3 squares that are shaded in. That's the numerator. The denominator is going to be the number that is circled. So 1, 2, 3, 4, 5, 6, 7, 8 becomes the denominator. Okay. If I were to represent this in just an equation, because maybe a model was not available, my first fraction stays the same, 1/4. I do the reciprocal of 2/3 to make it 3/2. Do the opposite of division, I multiply. 3 times 1 is 3, 4 times 2 is 8, and I get 3/8. It's always compared to the whole. Okay, let's go practice. So let's say we have 2/5 divided by 1/3. 3/8 divided by 1/2. 4/9 divided by 1/4. Let's go with 2/3 divided by 4/7. So practice those. Pause this and practice those before we move on to mixed numbers. Now, dividing with mixed numbers can be tricky. What you need to realize is you do need your mixed number into an improper fraction. So here I have represented, and you can say we have 3/2, which is the same thing as going 1 times 2, which gets 2, plus 1 more equals 3. Okay, and then what I want to do is see how many groups of 3/4 I can get out of my 3 groups of 1/2. So we're going to move down here where I have overlapped 1/4 pieces to see. So I have 3 1/4 pieces right here to represent one group in another set. So that has 1.5 divided by 3/4 equals 2. It's the same thing as if I wrote this out as an equation. 3/2 divided by 3/4 equals. Same process we've been doing before. Our first fraction remains the same. We do the reciprocal of the second fraction. We do the opposite of division, and that gets us 12/6. So when we simplify that, that equals a 2. Okay, so let's think about practicing. So if I have 2.5 divided by 1/3, 3 1/3 divided by 1/4, 1 2/5 divided by 3/4. Let's do a mixed number by a mixed number. So 2 2/3 divided by 1 4/5. So try those out. Pause this. Take your time, and remember, improper fraction first for anything that's a mixed number before you do the division process.